Although the terms AI and ML, or artificial intelligence and machine learning, are in vogue for the last various decades, but still there is a lot of confusion that what exactly is the difference between AI and ML, or how one could define both of them in simple words. In this video, I'm going to try to differentiate between AI and ML and what are the use cases for both of these. So let's get right into it. Let's first discuss what is AI. At its simplest level, AI can be split into two categories: general artificial intelligence and narrow artificial intelligence. Narrow artificial intelligence is a collection of technologies that rely on algorithms and programmatic responses to simulate intelligence, generally with a focus on a specific task. For example, when you use a voice recognition system like Amazon Alexa to turn on the lights, that's narrow AI in action. Alexa may sound smart, but it doesn't have any advanced understanding of languages and cannot determine the meaning behind the words you speak. The program simply listens for key sounds in your speech, and when it detects them, it follows its programming to execute certain action. To users, this can seem surprisingly intelligent, and voice recognition is far from a single computing task. But in reality, there is no actual thinking going on behind the scene by Alexa. Non-player characters, or NPCs, in games are another good example of ANI, or artificial narrow intelligence. While they take human-like actions, in reality they are simply following a pre-programmed series of actions designed to mimic how a human would play the game. So that is one type of AI, which is narrow AI. Let's have a look at what is general artificial intelligence, or GAI. GAI, in contrast, is intended to think on its own. The goal of GAI research is to engineer AI that learns in a manner that matches or even surpasses human intelligence. GAI is designed to learn and adapt to make a decision tomorrow that is better than the one it made today. None of this is easy, which is why most examples of AI you'll encounter today are the narrow form. GAI is a new, complex, and varied category with numerous sub-branches, most of which are still research topics in a lab. Modern AI systems focus on solving specific tasks such as optimization, recommendations, or prediction systems, and don't learn broad concepts generally like a human world. So GAI is the one which is really threatening everyone, but still it is far away. So now we understand what exactly is the AI, or artificial intelligence. Now let's have a look at machine learning, or ML. Simply put, machine learning is a specific type of artificial narrow intelligence with the goal of giving a computing device access to some store of data and allowing it to learn from it, but nowhere near the general artificial intelligence levels. As I mentioned before, when Alexa turns on the lights, it doesn't actually learn anything. Even if it does better recognize your voice over time, when the user tells Alexa to turn off the lights, a program is then executed to carry out the command. This is an example of a rule based approach, which is one of the simplest forms of AI, where the system operates on rules coded through if then else statements. But machine learning systems can do a lot more. When giving a data feed, say temperature and tolerance information from sensors on a piece of manufacturing equipment, and be asked to draw conclusions about it based on observed examples of a task. This may involve searching the data for trends, patterns, and anomalies, or any information that might not be obvious to a human observer. In the case of manufacturing, the machine learning algorithm would learn to send proactive alerts when temperature exceeds a certain threshold, so operators can take action before an issue arises. How is this all possible? Machine learning is a subset of AI that includes supervised, unsupervised reinforcement and deep learning systems. Supervised machine learning algorithms and models use labeled datasets, beginning with an understanding of how the data is classified, whereas unsupervised models use unlabeled datasets and figure out features and patterns from the data without explicit instructions or pre existing categorizations. Reinforcement learning, on the other hand, takes a more iterative approach. Instead of being trained with a single dataset, the system learns through trial and error and receiving feedback from data analysis. With faster and bigger computation capabilities, machine learning capabilities have advanced to deep learning, a specific kind of machine learning that applies algorithms called artificial neural networks composed of decision nodes to more accurately train machine learning systems for supervised, unsupervised, and reinforcement learning tasks. Deep learning approaches are becoming more widespread, but they come with high computation costs and are often harder for humans to interpret because the decision nodes are hidden and not exposed to the developer. On the whole, the AI and ML space is constantly evolving. The important thing is that understanding that these technologies can be applied to solve business problems as long as there is data to train them. And the better the quality of the data is, the better your machine learning AI experience would be. I hope this was useful. If you have any feedback, please put them in the comment section. Thank you.